Okay, what if I told you that everything we think we know about the universe is, well, wrong? We've always imagined it as this giant empty box with stars and galaxies scattered inside. But a new theory, a really radical one, suggests something completely different. It paints a picture of the cosmos as a single, connected, quantum fluid. Yeah, you heard that right.
For a long, long time, we've had this rule book for the universe called the Standard Model. It's been our trusted guide. But lately, it's been showing some serious cracks. Our best telescopes are sending back this incredibly precise, high-fidelity data, and it just doesn't line up with the old theories. We're at a point where we have to ask, did we get the fundamentals wrong?
So, let's get right into it. This crisis in the cosmos really kicks off with the James Webb Space Telescope. I mean, this thing is a time machine. It's looking back to the literal dawn of the universe. And what it's finding there, well, it's finding things that just flat out shouldn't exist. Not yet, anyway.
Way, way back in the early universe, Webb spotted a black hole. And look, this wasn't just any black hole. This thing was an absolute monster. We're talking 300 million times the mass of our own sun. To put that in perspective, the supermassive black hole in our galaxy, Sagittarius A star, is about 4 million solar masses. So this new discovery, it's not even in the same league.
But you know what? The size isn't even the craziest part. It's when it existed. This thing was already fully formed just 500 million years after the Big Bang. That's nothing in cosmic terms. The universe was just a baby, and it already had this giant that, according to everything we thought we knew, should have taken billions and billions of years to form.
And right here, this is the heart of the problem. Our current theory, what you could call the light seed model, says black holes start small, from a single collapsed star, and they have to grow slowly, gobbling up gas and dust over eons. But there's just no way to get from that to a 300 million solar mass monster in only 500 million years. The math just doesn't work. It's like finding a fully grown oak tree an hour after you planted the acorn. The old model just breaks.
You know, a crisis like this in science is actually a good thing. It forces us to think outside the box. And that's where this new, really mind-bending idea comes in. It's called the superfluid universe theory. And it doesn't just try to explain these weird black holes, it tries to explain everything.
Okay, so the core idea here is a total game changer. I want you to completely forget the idea of space as this empty void, like a stage where stars and galaxies are the actors. Instead, imagine the stage is the actor. The theory says the entire universe is made of one single coherent thing, a quantum superfluid.
All right, let's unpack that, because it's a big idea. Point 1. There's no such thing as empty space. No vacuum, nothing. The universe isn't a box with stuff in it. It's more like an ocean, and even the emptiest parts are still filled with, well, the ocean. And if we stick with that ocean idea, then point 2 is even wilder. Everything we see, stars, galaxies, planets, you, me, we aren't just things floating in the superfluid. We are the superfluid. We're just different patterns, like whirlpools or currents or waves, all part of the same cosmic substance.
And this all leads to the third, and maybe most elegant part of the theory. Forces like gravity, they're not some mysterious invisible thing pulling us down. They're just ripples, disturbances traveling through the superfluid, kind of like sound waves moving through the air. In fact, scientists have a name for these cosmic sound waves. They call them phonons.
So, I know what you're thinking. This sounds pretty out there. A cosmic ocean, ripples of gravity. But here's the beautiful thing about science. If this wild idea is true, it shouldn't just explain away old problems. It should also predict new, weird things that we can actually go out and look for.
And that right there is what separates a cool sci-fi story from actual science. A real scientific theory has to be testable. It has to stick its neck out and say, hey, if I'm right, here's what you should go find. And believe me, the superfluid universe theory makes some really bold, really specific predictions.
All right, check this out. Prediction number 1 is basically a race between light and gravity. Now, Einstein told us they should travel at the exact same speed in a vacuum. But in a superfluid universe, there is no true vacuum. The theory says that if a gravitational wave travels through a really dense part of the superfluid, like a galaxy's halo, it's like light passing through water. It should slow down just a tiny bit. So, if we see something like 2 neutron stars colliding, we should get the flash of light first, and then, a split second later, the gravitational wave should arrive. Finding that delay would be huge.
Next up, let's talk about the cosmic web. You know, those gigantic filaments that connect all the galaxy clusters? Well, in this model, they're not just these passive threads of dark matter. They're more like cosmic superhighways. They're active channels for energy to flow through the universe.
So get this. The theory predicts that a massive event over here, say 2 galaxy clusters colliding, could send a huge pulse, one of those phonons we talked about, shooting down a filament. And that pulse could travel millions of light years and then kickstart a wave of star formation in a completely different galaxy cluster over there. It would look like some kind of spooky action at a distance, but it would just be an echo traveling along the cosmic web. And it just keeps getting weirder. The theory also predicts we might find that the spins of galaxies that are millions of light years apart are somehow aligned, or that there's a faint echo in the distribution of galaxies left over from when dark energy first kicked in. We might even be able to detect tiny pops of gravitational waves coming from inside our own galaxy. All these things are signatures that the standard model has absolutely no explanation for.
Okay, that's a lot to take in, and it all sounds pretty incredible, right? But it brings us to the most important part of any scientific theory. How do we actually test it? I mean, how do you prove or disprove an idea about the entire universe?
Let's just be real for a second. We're talking about a cosmic superfluid, sound waves traveling between galaxies. Is this actual science, or have we just wandered into science fiction?
And the answer is a definite no. It's not fiction. And here's why. Every single one of those bizarre predictions is a concrete test. We can look for that time delay between light and gravitational waves. If we never ever find it, then the theory's in trouble. We can search for those spooky alignments between galaxies. If they're not there, the theory's wrong. See, this isn't just a cool story. It's a roadmap with clear directions.
Which brings us to a final, pretty deep thought. Maybe these impossible black holes that the Webb telescope found aren't a sign that our physics is broken. Maybe they're just showing us that our picture is incomplete. They could be the very first clue that we're not just living in the universe, but that we are literally a part of it. And if that's true, what else are we missing?